All right, so as we're looking at the quotient rule here, we have u prime of x times v of x minus u of x times v prime of x all over v of x squared. That's a lot, okay? However, notice here that u is always the numerator and v is always the denominator. And to simplify things a little bit, since it's always going to be, we're looking at these as functions of x, we can just write them as u and v. And then that makes it u prime v minus uv prime all over v squared. And you'll notice here the numerator looks really similar to the product rule. In fact, it's simply the product rule, but with subtraction. Okay? And then we put that over v squared. Okay? Now, in the formula booklet, this is what you'll see. They like to use the dy dx format. Okay? So dy dx is v, our denominator, times the derivative of the numerator, du dx, minus the numerator u times the derivative of the denominator over dx, all over the denominator squared. And if you want something that kind of rolls off the tongue a little bit easy, it's low d high minus high d low over low squared. Alright? Low is the denominator, high is the numerator. So the denominator times the derivative of the numerator, low d high, minus the numerator times the derivative of the denominator, high d low, all over low squared. Okay? Low d high minus high d low over low squared. If that helps you remember it, that's great. If not, forget it. Okay? So that's kind of a nice way to think of it. Alright? But I also want to see where this comes from. Because as you learned, who knows way back when, division is simply multiplication. But it's multiplication by the reciprocal of something. So when I'm dividing by 2, that's the same thing as multiplying by a half, the reciprocal of 2. Now if I think of this problem this way, where the function y is u divided by v, I could rewrite that as u times 1 over v. Which in turn I could rewrite as u times v to the negative 1. Okay? Everyone with me so far?
Yes.
Now, if I wanted to take the derivative of that, what would I use? The product rule. Product rule. And what'd you say, Alex?
I'm just kidding.
What'd you say?
I said nothing, don't worry.
No, come on, what'd you say?
I said chain rule, but I didn't mean that. I just meant like you have to do the thing.
Well, we are going to use the chain rule as part of the product rule because we don't just have a v, right?
Yeah.
We have a v to the negative 1. So that's a composite function we got to use the chain rule for. All right, so you were right. We've got product rule. Okay. So dy dx, you guys know is u prime v plus uv prime, but it's not just a v here. Okay. U prime is just u prime times v plus u times, and then here's the part that we got to figure it out. V prime, but instead of a v, we have a v to the negative 1. Okay? Now, the v here is going to be the inner function for the chain rule. Like Alex said, we got to use the chain rule here. The something to the negative 1 is our outer function. Okay? Well, what is the derivative of something to the negative 1?
Negative 1, something to the negative 2.
Negative 1, something, in this case a v, to the negative 2. But then we have to multiply by the derivative of the inner. The inner was v, so the derivative is v prime. There we go. V prime. Okay? So it's negative 1v to the negative 2 times the derivative of the inside, which is v prime.
One thing I just have like a general question about is like when you're finding the derivative of the inner, you would have like v, it would end up being like you take like the 1 because its exponent is 1, bring that to the front, and then you'd have v1 minus 1, right?
Negative 1 minus 1.
Well, isn't the inner in this case just v?
The inner is just v, yeah.
Right? So when you're taking the derivative of that, you bring the exponent that it has, which is 1, to the front. And then you have, and the exponent for v is 1 minus 1. So why doesn't that just leave you with 0 for the exponent?
That's a good question. Here we're differentiating with respect to x, not v.
Okay.
Okay? And I know that's a little abstract right now, but that's why it's not just the derivative of v is 1. Well, we're not differentiating with respect to v, we're differentiating with respect to x.
So if it was x, then it would just be 1.
You're right.
Okay.
Yes. Okay? Now, let's simplify this a little bit here, and I think you'll see where we're going, all right? So we have u prime times v, and then here's that minus. I'm going to put the negative 1 out in front, okay? Oh, wait, and sorry, the v wasn't a v. The v was a v to the negative 1. I lost my negative 1 there, okay?
Oh, that's right. Okay.
So, when I simplify this, it's actually going to be u over v. U prime over v. Sorry about that.
It's okay.
Minus the u and the v prime both have positive exponents, but that v to the negative 2, we don't like leaving negative exponents in our answer, so I'm going to put that v squared in the denominator. Okay? Now you'll notice these almost have the same denominator, so I'm going to go ahead and multiply by v over v to get a common denominator, and now I can put it together, and look what I have. U prime v minus uv prime over v squared. Low d high minus high d low over low squared.
Oh my god.
There's our quotient rule. The quotient rule is simply the product rule where the second factor is to the negative 1 power. Yes?
What happened if you messed up the order?
If you mess up the order as far as the u prime and v, that doesn't matter because that's multiplication, so it's commutative. If you mess up like which one is the top and which is the bottom, it's going to mess everything up. Okay? So with the multiplication, yeah, low d high would technically be vu prime. Okay? But the multiplication can be either order. In fact, depending on what book or website you look at, you'll see it written the opposite direction. Or even right here, they put v times du dx just to make it look a little bit better there. So that part, the order doesn't matter. Okay? All right, so let's look at a few examples here. This first one I already did, so you can refer back to that. You could try practicing that one on your own and then come back to it. But let's use this one here as our practice. First of all, what is u?
Wait, is that on the...
This is all on day 1.
Okay.
This is the second example.
Okay.
So u is x squared. U is always the numerator. And that means that u prime equals 2x. Okay? V is... Yeah, v is that denominator, 3x minus 1. So v prime equals... 3. V prime equals 3. So, at this point, we can find dy dx using our formula. U prime v minus uv prime all over v squared. Okay? So u prime we found was 2x times v is 3x minus 1. Minus u times v prime. So x squared times 3. That's all over a 3x minus 1 squared. Okay? Now someone tell me, why can I not cancel out the 3x minus 1s?
It's getting 1 by 2x.
Yeah, we have a minus x squared times 3. Okay? That's a really common, silly mistake people make a lot on these, unfortunately. Please don't do that. Alright? All we have to do at this point is simplify our numerator. So we're going to distribute the 2x, and I get a 6x squared minus the 3x squared on the end. So that's going to give us 6x squared minus 2x minus 3x squared over 3x minus 1 squared. So that's a 3x squared minus 2x all over 3x minus 1 squared. Okay? Now, one question students have a lot is, okay, well, on the numerator there I see that I could factor out an x. Do I have to do that? The answer is only if it will help you reduce the fraction. You say, well, how do I know if it'll help me reduce the fraction if I haven't factored it yet? Well, we'll look at that later, okay? Basically, you need to try to make it work, and if it doesn't, then don't bother trying to find how it actually factors. We'll look at that in a minute. But here, if you wanted to factor out the x and make that a 3x minus 2, you can. And in fact, next unit when we do applications, you're going to want to, because we'll be setting these equal to 0 and figuring out what they equal. But for now, either of these answers would be perfectly acceptable. 3x squared minus 2x over 3x minus 1 quantity squared. Now this example I've already done, but I want to use this to illustrate some simplifying and illustrate what I was just talking about you only need to factor if it will help you reduce the fraction. Okay? So let's look at this example up here. I've done the whole process, okay, and I get this right here. Okay, and you might say, well, before we didn't have to simplify if we had to FOIL. This is an exception, okay? First of all, do not ever FOIL the denominator. It's never really going to be helpful, okay? Now, there might be cases where it's over the square root of something, so actually multiplying it will just undo the square root. That's fine. Of course you want to, the square of a square root, the square root's gone. But don't FOIL the denominator when it's like 5x squared plus 2 quantity squared, okay? Don't bother trying to copy all this down right now. You could get this from the notes later. These notes here, though, on the side, you might want to write down, okay? Do not FOIL the denominator. In the numerator, here's what you're going to do. First of all, look for common factors. Just like we had in the product rule, if you have to do the chain rule to find u prime or v prime, you're going to have common factors. And then you can factor it out. Now, in this case, we didn't have that. All right, so we are going to multiply things together and combine like terms. Because we have this subtraction here, I want to try to combine any like terms I can. So I'm going to FOIL this, and I get 60x to the fourth plus 24x squared minus 35x squared minus 14. And then here at the end, I'm going to distribute the negative and distribute the 10x, and I get a minus 40x to the fourth plus 70x squared. Okay? So notice I have some like terms. 60x to the fourth minus 40x to the fourth is 20x to the fourth. I've got a bunch of x squareds that come out to a 59x squared, and then I have the minus 14. Okay? Now you'll notice here, I tried factoring the numerator, but I only tried it once. I'll actually show you this part. In order for factoring in this case to be useful to us, it'll only be useful if one of the factors is identical to the 5x squared plus 2, because then I could cancel one of them out. Alright? So what I did here is I wrote down a 5x squared plus 2, and I said, okay, well, what would the other factor have to be if that's the case? Well, to get a 20x to the fourth, I'd have to have 5x squared times a 4x squared, right? And in order to get a negative 14 at the end, I'd have to have a positive 2 times a negative 7. So now, if I check the outers and inners, I get a negative 35x squared and a plus 8x squared. Is that going to give me 59x squared? No. So that means that there's no way I can factor the numerator and get something that will cancel with anything on the denominator. So I'm not going to bother factoring at all at this point. Okay? So, that's what I was talking about when I said you only need to factor if it'll actually help you reduce. So you should check it, but you only need to check one option really. Okay? Alright, so let's work through a couple of other examples. Okay, let's, on the next page here, I'm actually going to do the 4x squared over x cubed plus 3 first, and then we'll come back to the previous one. Okay? So, what is u? 4x squared. So that means u prime equals 8x. What's v? X cubed plus 3. Good. So what's v prime? 3x squared. So now, let's use our rule. Okay? dy dx is u prime v minus uv prime all over v squared. So u prime is 8x. V is an x cubed plus 3 minus u 4x squared times v prime 3x squared all over, yep, x cubed plus 3 squared, the v squared. Now, here's what I was talking about when I said before you, or as you're simplifying the numerator, look for common factors that you could pull out. We have the u prime v and the uv prime. If they have any common factors, let's pull those out, because that'll make life easier in the future. So what would the common factor be? Not an x squared, just an x. And what about the coefficients? We could pull out a 4. All right, so that's going to leave a 2. I'll put brackets here. That's going to leave a 2 times x cubed plus 3 minus, if I pull out a 4x, that's going to leave us with a 3x cubed. and that's x cubed plus 3 squared. Now I want you to get used to looking for that common factor, because when we start applying this, being able to simplify this way is going to be invaluable.
So you took the 4x and the 8x and 4x?
Yes.
Okay. Now, I thought that if you picked one out, it would have to be the whole, like everything had to. Never. I get it.
I think what's confusing you, this, oops, let's get rid of that. This is multiplied by this, so that's all one factor, and this is all multiplied together. So when I'm looking for common factors, I can pull out any factor within those.
Okay.
So that's why I can pull the 4 out of both of those and an x out of both of those.
Okay, thank you.
Okay.
Can we also just distribute them and then try to pull out the common factors, or?
You can distribute and then pull out common factors if that helps. Later on it might get a little complex, so that's why it can be helpful to just do it at the beginning. Alright, now that I'm here at the end, I have 4x times a 2x cubed minus 3x cubed is a negative x cubed plus 6. And that's all over x cubed plus 3 squared. And that's my final answer. Okay. Alright, let's do one last example. X to the 9th minus 1 over the square root of x squared minus 1. This one gets a little bit complicated, but stay with me here. And why do you think this one might get a little complicated?
There's a radical in this denominator.
Yeah, so our denominator, the v, is actually composite. So we're going to have to use chain rule. Okay? So, let's start with the easy part. U is the numerator, so what's u prime?
9x to the 8th.
Yeah, 9x to the 8th. Okay? V prime gets a little more complicated. So v, I'm going to actually rewrite as x squared minus 1 to the 1/2. So what is... Well, when you're identifying v, forget about the fact that it's in the denominator. Just, it is what it is. Okay? That's a good question, though. You just pull it out of the denominator, and that's what v is. Okay? Now, when I take v prime, what's that going to give me?
1 over 2 times x squared minus 1 to the negative 1 over 2 times 2x.
There we go. There's our chain rule. 1/2, the derivative of something to the 1/2 is 1/2 something to the negative 1/2 times the derivative of something. So it's 1/2 x squared minus 1 to the negative 1/2 times 2x. Now this, I don't want you to simplify the negative at this point. Alright? It'll actually be easier, and you'll see that in a sec. So here what we have is, I will simplify the 1/2 times the 2x, so it's going to be x times x squared minus 1 to the negative 1/2. Okay? So that is our v prime. So here comes our formula. Okay? dy dx. U prime, 9x to the 8th, times v. I'm going to write it with the 1/2 power, just for ease here, or consistency. Okay? Minus u, x to the 9th minus 1, times v prime. So I've got the x squared minus 1 to the negative 1/2. And this is going to all be over v which is the square root of x squared minus 1 squared.
So just x squared minus 1.
So yeah, that square will undo the radical in this case. Okay? So yes, our denominator is going to just be x squared minus 1. Now, here's the part that can be a little complicated if you're not careful. You'll notice that I do have an x in common, so I'm going to pull out an x. However, you'll also notice that I have an x squared minus 1 in common. Where this can get tricky is, okay, well, what do I actually pull out? Because one of those is to the half power and one is to the negative 1/2 power. Does anyone remember what we said when we were doing product rule? Which one would we pull out? X squared minus 1 to what power? The negative. You always pull out the one with the lower power.
Oh, that's right.
Okay? So we're going to pull out the negative 1/2. Now, let's look at what happens as a result. First of all, I pulled an x out of the 9x to the 8th, so now it's 9x to the 7th. But if I pull out a negative 1/2 power and I originally had a positive 1/2 power, what's going to be the leftover part?
Negative.
Think about it. I got to multiply these back together to get a positive 1/2. If I'm multiplying, what do I do with exponents? I add them. So negative 1/2 plus what would give me positive 1/2? 1. So it's just 1. Okay? That's the part that can be a little bit tricky. Because negative 1/2 plus a positive 1 will give me the positive 1/2 that I had originally. Alright, so you can always double check yourself that way. That's kind of the tricky part here. But you'll see why we do that in a second. Okay, now I look at the rest of this, it's minus, I took out everything except for the x to the 9th minus 1, so here's x to the 9th minus 1. Okay, so now all we have to do is simplify at this point. And you'll notice here, I have a factor that has a negative 1/2 power. What can I do with that? I can put that in the denominator. That's why we pull it out like that. So now I have x squared minus 1 to the first power, and I'll also have it to the 1/2 power. So now if I have it to the first power and to the 1/2 power, I could write that as x squared minus 1 to the 3/2 power, yeah. So I brought this down to the bottom. Okay?
Oh, like because it's negative and like it's the same thing as 1 over.
Yeah. So now I still have an x in my numerator and I need to simplify the brackets. The brackets are 9x to the 9th minus an x to the 9th. So that's 8x to the 9th. Minus 9x to the 7th plus 1. If I simplify what's in the brackets there. And that would be my final answer.
Where's this 8x?
The 8x to the 9th, because you do 9x to the 7th times x squared is 9x to the 9th, and then minus the x to the 9th over here.
You would have to distribute x inside the brackets?
No, don't.
Okay.
Just leave that alone. If it's already factored, leave it factored. Okay? So that one is a bit complex, but we'll see these more as we move on, and being able to handle them like this will be really useful. It'll make life a whole lot easier later on. Okay? Any questions? Okay.